Alright, so on this problem we're trying to solve for the magnitude of the acceleration, and we are given the mass and force, so that means we're going to use acceleration is equal to force divided by mass. So we take 10 newtons divided by 1 kilogram, and you should get 10 meters per second squared. Alright, on this problem it says a car travels at a constant velocity. The net force on the car is. If you're traveling at a constant velocity, you do not have acceleration, so therefore there is no net, the net force on the object would be 0. Alright, this one says suppose a cart is moving or being moved at a certain net force. A load is added to the cart so its mass is doubled. What is the ratio of the acceleration to the old acceleration? So if you increase your mass, then you must decrease your acceleration, and it is proportional to the increase in mass. So if we increase our mass times 2, then that means we must decrease our acceleration by 1/2, because it's got to be inverse, or we divide by 2. So your answer should be 0.5. Okay, this one is saying that you have a net force on the object of 3.0 kilograms. The net force is 9.3 newtons, and it wants to know the acceleration of the plane. So whenever we're solving for acceleration, we always use A equals F divided by mass, force divided by mass. If you need help with that, force is equal to mass times acceleration. To solve for A, we divide both sides by m. So mass goes away, acceleration is equal to force divided by mass. So the acceleration is equal to 9.3 newtons divided by 3.0 kilograms. That will give you 3.1 meters per second squared. Remember that your numbers will be different than mine on this problem, but I am showing you how to work it out. Force divided by mass. Okay, we have a net external force on a golf cart is 410.1 newtons north, and the cart has a total mass of 27.9 kilograms. What is the car's acceleration? We're using the same equation. A is equal to force divided by mass, where the force is 410.1 newtons, and the mass is 279.8 kilograms. Right? Make sure you add in that it's to the north because acceleration is a vector. So whatever it'll be meters per second squared to the north. And if you give me a second, I'll go ahead and do the math. So we get 1.47 meters per second squared to the north. Alright, this problem we're solving for the acceleration again. So we have acceleration is equal to your force divided by your mass. The golf cart has an external force of 409 newtons to the north, and we're going to divide by its mass as 252 kilograms. You'll get meters per second to the north, and just a moment. You get 1.62 meters per second squared to the north. So if you come over here and find your answer, 1.63 would work. That's our best answer choice over there, and go from there. Alright, so first off, when we're solving this, you've got a forward force of 7.2 newtons forward. You have a mass of 3.0 kilograms, and you will solve that out to get 2.40 meters per second squared. So your answer is number 9 in this case. Remember to use your numbers for this problem. Alright, so we know that we have a change in velocity of 41.2 meters per second, and the time is going to be 24 seconds. We know the mass is 2.7 kilograms. Okay, so you're going to use your acceleration equation. We know that acceleration is equal to your delta V over your delta T. And then you're going to multiply that by the mass to find your force. So in this case, your force is going to be equal to your mass times your delta V divided by delta T. Just plug it in from there. So when you plug the numbers in there, you should see that it is 2.7 times 41.2 divided by 24 will give you your force. It's 4.64 newtons.